Ever wished you could like shrink down those massive AI models?
Mm.
The ones everyone's calling LLMs?
Mm-hmm.
Well, today we're taking a deep dive into a technique that does just that.
Okay.
It's called information bottleneck fine-tuning.
Interesting.
Imagine like a friend trying to summarize a huge, super complex novel for you,
Okay.
but instead of give you every little detail,
Mm-hmm.
they just highlight the key plot points that you absolutely need to understand the ending.
I see.
That's essentially what IB fine-tuning does. We're looking at excerpts from a research paper, Efficiency and Performance Optimization in Large Language Models through IB Fine-Tuning.
Okay.
And this is by some really bright researchers from the Indian Institute of Information Technology.
It's a really fascinating approach because it's not just about making the model physically smaller.
Right.
It's more about making it more efficient
I see.
by figuring out what information is really truly essential for a specific task, and then anything else, just discarding it.
So it's like decluttering the model's brain, helping it focus on what really matters.
Exactly. And this is especially important in the world of fine-tuning.
Right.
For those who might not be familiar, fine-tuning is like taking an LLM, which already has all this vast general knowledge,
Right.
and then training it to be an expert in a very specific area.
Okay.
Think of it like training someone who already aced English literature, to become a whiz at like writing movie reviews or analyzing social media trends or something like that.
Okay, that makes sense.
Yeah.
But why do we need this information bottleneck if fine-tuning already kind of does that?
Well, traditional fine-tuning has a couple limitations.
Okay.
One major issue is something called catastrophic forgetting.
Catastrophic forgetting.
Yeah, it's like when a student crams so hard for a test they forget everything else they've learned.
Okay.
LLMs can kind of suffer from this too.
Oh.
They might become so focused on this new task that they lose some of their broader knowledge.
So you're saying my super smart AI could forget how to do basic math because I've taught it to write poetry?
Yeah, exactly.
That seems counterproductive.
Exactly. And then there's another challenge too.
How?
Fine-tuning these massive models, especially with tons of data, it can be super resource intensive.
Right.
It takes a lot of computing power and energy.
Mm-hmm.
And that's not ideal for everyone.
So we've got these potential problems of forgetting and resource consumption.
Right.
Is that where information bottleneck comes in to save the day?
That's exactly it. IB aims to make that fine-tuning process more efficient and less prone to forgetting.
Gotcha.
Remember our book-loving friend?
Yeah.
Imagine they've distilled like a 1,000-page novel down to a 10-page summary.
Okay.
But they keep only the plot points and characters that are vital to understanding like how the story ends.
Right.
They've created an information bottleneck.
Okay, I'm starting to see the analogy here.
Mm.
But how do you actually apply that to an LLM? With millions of data points, how does the IB method choose what to keep and what to just toss out?
That's where this research gets really interesting. These researchers use two key metrics to guide that IB fine-tuning process.
Oh.
Compression effectiveness
Okay.
and predictive relevance.
Okay.
So two things. It's kind of like walking a tightrope. You're trying to find that perfect balance.
Okay, let's break those down a bit.
Yeah.
Compression effectiveness sounds like, just making the model smaller,
Right.
more efficient.
Exactly.
But what about this predictive relevance?
That's all about making sure that even though we're compressing the model, it doesn't lose its ability to do the specific task it's been fine-tuned to do.
Right.
We still want it to be, lean and efficient, but still incredibly good at its job.
So it's a trade-off, right?
Yeah.
Finding that sweet spot between making the model smaller but making sure it doesn't sacrifice performance.
Yeah.
Did the researchers actually find that sweet spot? Like, did this whole IB thing actually work?
What's remarkable is not only did it work,
Okay.
but in certain scenarios, it actually outperformed other leading fine-tuning methods.
Wow, okay.
For example, on a benchmark test for question answering, the IB-tuned model achieved a 5% higher accuracy compared to a model that was fine-tuned using like a standard method.
Okay, now that's impressive. So smaller model, fewer resources needed, and even better accuracy in some cases.
Yeah.
But this all sounds kind of abstract. Is there any way to actually see this IB magic at work?
Here's where it gets really cool.
Okay.
They actually visualized the attention patterns of the LLM before and after IB fine-tuning.
Okay.
Think of it like, looking into the model's mind,
Yeah.
seeing how it's processing information.
Wait, so they could actually see the effect of IB on the model's attention?
Yeah.
Tell me more.
One example that stood out was how the model was analyzing IMDb movie reviews.
Okay.
Before IB, its attention was kind of all over the place.
Right.
But after IB fine-tuning, it was laser-focused on the keywords and phrases that actually carried the sentiment of the review.
Gotcha.
It's like the model learned to ignore the fluff, zero in on what truly mattered.
So instead of getting bogged down by every word in a review, it learned to pick out like the key words that revealed whether someone liked or disliked the movie.
Yeah, exactly.
That's incredible.
And this ability to visualize those attention patterns.
Yeah.
It's important not just for, understanding how IB works, but also for building trust in AI.
Right.
If we can see how the model is making decisions, we can start to use it more responsibly.
That's a great point. It's like lifting the curtain on the AI's decision-making process.
Yeah.
Which I think is essential as these models become more integrated into our lives.
Right. And this research has some potentially huge implications for you and anyone else who's, interested in AI. Imagine running powerful AI models on your phone or other devices with limited computing power without having to sacrifice performance.
That's the future IB fine-tuning could enable.
Yeah, potentially.
Okay, now my mind is racing. Lightning-fast language translation on my smartwatch. Personalized learning apps that adapt, in real time.
Yeah.
The possibilities seem endless.
This research could really democratize AI.
Yeah.
Making it accessible to a much wider range of users and applications.
This is already blowing my mind. But we're just getting started, right? There's much more to uncover about this information bottleneck.
Yeah.
And its potential. What else did these researchers discover when they, put this technique to the test?
Well, they didn't just stop at demonstrating that IB works.
Okay.
They actually dug deeper, exploring different training parameters and how those impacted the performance of the IB-tuned models.
So they were tweaking and experimenting, trying to find, the perfect recipe for making IB work even better.
You got it.
Cool.
They looked at things like batch size, how much data you feed the model at once.
Yeah.
Different types of activation functions, which are like little mathematical switches that determine how the model processes information.
Those bring back memories of my AI 101 class. So it sounds like they were conducting a symphony of experiments with the model.
Right.
Trying to fine-tune the fine-tuning, so to speak.
Exactly.
What were some of the highlights? What really stood out in their findings?
One really interesting discovery involved the ReLU activation function.
Okay.
They found that using ReLU consistently resulted in better performance compared to other popular choices like Sigmoid or TAN.
And remember, they tested this with the Llama 2 model.
Yeah.
Which is one of the most powerful LLMs out there.
Yeah.
So these findings have, real-world implications for how these cutting-edge models are trained and optimized.
Absolutely. They also discovered that the choice of optimizer, which is a special algorithm that helps the model learn more efficiently, could significantly impact the model's ability to generalize its knowledge to new tasks.
So it's not just about compressing the information.
Yeah.
It's about finding the right tools and techniques to train the model so it can effectively apply that compressed knowledge.
Exactly.
It sounds like there's a real art to this.
Absolutely. It's like giving the LLM a toolbox equipped with the best instruments for navigating the complexities of language.
This is all so fascinating.
Yeah.
But I have to admit, I'm feeling a bit overwhelmed by all these technical details.
Yeah.
I think some of our listeners might be too.
You're right. We've gone pretty deep down the rabbit hole here.
Yeah.
But the big takeaway is that this research is really pushing the boundaries of AI, making these powerful language models more accessible.
Okay.
And more understandable.
And that's the heart of what we do here right now.
Yeah.
On the deep dive, giving you the tools and the knowledge to navigate this incredible world of AI.
Even if you don't remember all the technical terms, hopefully, you'll walk away from this with a sense of awe at what's being accomplished.
I couldn't have said it better myself. But there's more to this research.
Yeah.
The researchers went beyond testing IB on just one model. They actually decided to stage an LLM Olympics.
Okay.
Pitting different LLMs against each other.
Interesting.
To see how they performed on various tasks.
Cool.
And it wasn't just tests of raw power or size.
Right.
The researchers wanted to see how each model performed under different conditions. How well they learned from limited data sets.
Okay.
To give us a more realistic view of their capabilities.
Oh, I see.
So an AI obstacle course, testing their agility and adaptability. That's awesome.
Yeah.
Which LLM took home the gold?
Well, in the text generation challenge using the Wikitext2 dataset, the winner was the text-to-text transformer, or T5 for short.
T5? That's not a name I hear as often as like GPT-3. Is it one of those massive models with like billions of parameters?
While impressive, T5 isn't actually the largest model out there.
Okay.
What's remarkable about its performance is like its efficiency and adaptability. It achieved great scores, even when it was trained on very limited data.
So it's not just about brute force. It's about working smarter, not harder. Like David going up against Goliaths and coming out on top. I love that.
It's a great example of how, clever engineering and training methods like IB fine-tuning can make a huge difference.
Right.
But hold on to your hats.
Okay.
Because the surprises didn't end there.
Okay. What else happened?
When they moved on to sentiment analysis using the IMDb movie review dataset, guess who stole the show again?
Let me guess. T5.
You got it.
Wow. Okay.
And this time it was a smaller version called T5 Small that outshone the larger models.
Hold on. A smaller model outperformed the giants on sentiment analysis. That's mind-blowing. It really highlights how IB fine-tuning can, unlock the potential of those more compact models.
Exactly. It's all about focusing on the most relevant information.
This is making me rethink the future of AI on devices like our smartphones. Imagine having incredibly accurate sentiment analysis running on your phone.
Right.
Without, draining the battery in 5 minutes.
It's an exciting possibility.
Yeah.
And it's all thanks to research like this, which is making AI more accessible and more sustainable.
Okay, I'm dying to know, how did the big names like GPT-3 and Llama 2 fare in these LLM Olympics? Were they, completely overshadowed by T5?
Not at all.
Okay.
They still put up a strong fight.
Okay.
Especially in tasks that had, a lot more training data. For
Right.
instance, Llama 2 performed exceptionally well on text-to-text tasks using the massive C4 dataset.
So there's still a place for those, massive models, when you have the resources and the data to train them effectively.
Right.
But it's encouraging to know that smaller, more efficient models can, hold their own.
Yeah.
Thanks to techniques like IB fine-tuning.
Exactly. It's all about choosing the right tool for the task.
Right.
And techniques like IB fine-tuning are giving us more options than ever before.
Yeah.
It's truly an exciting time to be following this field.
This whole deep dive has been a whirlwind of information, and we've only just begun to scratch the surface.
Right.
Before we move on to the next chapter of this research, let's take a moment to recap what we've learned so far. We started by introducing the concept of information bottleneck fine-tuning. And how it aims to make LLMs more efficient and less prone to, forgetting.
Right.
We then explored how the researchers use those two key metrics, compression effectiveness and predictive relevance,
Yeah.
to find that sweet spot between shrinking the model and maintaining performance. And remarkably, they found that IB-tuned models often outperform their counterparts in, accuracy and efficiency.
Absolutely.
We even got to peek behind the curtain
Yeah.
and see how IB impacts the model's attention, focusing it like a laser on the most relevant information.
Right.
And to top it off, we got a glimpse of the LLM Olympics,
Yeah.
where we saw that size isn't everything. And techniques like IB can empower those smaller models to compete with the giants.
It's an exciting development.
This deep dive has been a whirlwind tour of the latest advancements in, LLM optimization.
Yeah,
But it's just a glimpse into the incredible potential of this field.
for sure.
I'm already buzzing with excitement about all the possibilities. But before we get ahead of ourselves, let's take a moment to explore another fascinating aspect of this research. The researchers didn't just stop at comparing different LLMs.
Yeah.
They also dug deep into the, nitty-gritty of how these models are trained, experimenting with various parameters to see how they could squeeze even more performance out of these IB-tuned LLMs.
It's like they were conducting an intricate AI experiment.
Yeah.
Carefully adjusting all these variables.
Right.
To unlock the model's full potential.
Fascinating. And they discovered some truly intriguing results.
They did.
They did, and they discovered some really intriguing results.
They really went all out testing different parameters to see how they could optimize these IB-tuned LLMs. They explored things like batch size, different types of activation functions, loss functions, even various optimizers. It was a comprehensive analysis.
Hold that. Let's unpack that a bit.
Yeah.
I remember activation functions from my AI 101 days. but it's all a bit fuzzy.
Yeah.
Remind us what those are and why they matter in this context.
Think of activation functions like tiny switches inside the model that determine how information flows.
Okay,
They decide which neurons like fire and contribute to the final output.
I see.
So choosing the right activation function can really impact how well the model learns.
So it's not just about feeding the model data, it's about making sure the information is processed in the most effective way.
Exactly. And they experimented with several popular ones like ReLU, Sigmoid, and Ton, each with its own little quirks. It's like trying different spices in a recipe to see which one brings out the best flavor.
Okay, that analogy helps. And what about those other things you mentioned, like loss functions and optimizers? What role did they play in training these models?
Well, a loss function essentially measures how well the model is doing during training. Yeah, it tells us how far off its predictions are from the actual results.
Okay.
The goal is to minimize this loss and get the model as accurate as possible.
So it's like a feedback mechanism telling the model, hey, you're getting warmer, or nope, you're way off.
That's a great way to put it. And then you have optimizers, which are algorithms that help the model learn more efficiently. They kind of guide the model's adjustments based on the feedback from the loss function.
So the loss function tells the model how it's doing, and the optimizer helps it improve. It's like having a coach and a personal trainer for your AI.
That's a fantastic analogy. And the researchers meticulously experimented with different combinations of these parameters, like a conductor fine-tuning an orchestra to create a harmonious sound.
So did they find any magic formulas? What were some of their aha moments?
One standout finding was that using the ReLU activation function consistently led to better performance compared to other popular choices. It seems ReLU just works really well with this type of IB fine-tuning.
And remember, this was all done using the Llama 2 model,
Yeah,
a powerhouse in the LLM world.
right.
So these findings could potentially influence how these cutting-edge models are trained in the future.
Absolutely.
It's pretty exciting.
Another fascinating discovery involved the optimizers. They found that using an optimizer called AtomW led to significant improvements in the model's ability to generalize its knowledge to new tasks.
So it's not just about squeezing information. It's about making sure the model can apply that compressed knowledge effectively. What stood out to you the most from all these experiments?
What fascinates me is the interplay between these different parameters. It's not a one-size-fits-all situation. Finding the optimal combination is like solving a complex puzzle. And it highlights the need for careful, meticulous experimentation in AI research.
You're right. It's like a delicate balancing act. And the researchers' willingness to dive deep into these technical details is what makes this research so valuable. It's not just about showing that IB works. It's about understanding how to make it work even better. This deep dive is making me realize just how much goes on behind the scenes when training these powerful AI models. It's not just about throwing data at them and hoping for the best. There's a real science, even an art, to finding the right techniques and parameters to unlock their full potential.
And that's what makes this field so exciting. There's always more to learn, more to explore. And the researchers didn't stop there. They went a step further and compared the performance of different LLMs, each with its own strengths and weaknesses on various tasks and data sets.
So they weren't content with just optimizing one model. They wanted to see how IB fine-tuning affected a whole range of LLMs.
Yeah.
There's some serious dedication to pushing the boundaries of AI.
Exactly. They were curious to see how IB impacted models of different sizes and architectures, and if there were any patterns or surprises that emerged, just like comparing different athletes in a decathlon to see who excels in which events.
I love that analogy. So who were the contenders in this AI decathlon, and were there any unexpected champions?
Well, they tested a diverse lineup, including some heavy hitters like GPT-3, Llama 2, and even a few lesser-known models like T5 and Distilbert. Each model brought its own unique strengths to the table.
Okay, I'm on the edge of my seat. Spill the tea. Who dominated the competition?
Was there a clear winner? Interestingly, there wasn't a single model that outperformed all others across every task. It really depended on the specific challenge and the amount of training data available.
So it's not a simple case of one LLM being superior to all others. It's more nuanced than that, which makes sense.
Exactly. For instance, they found that GPT-3, with its massive size and vast knowledge base, excelled in tasks involving generating creative text formats like poems or scripts. However, it struggled a bit when faced with tasks that required reasoning and logical deduction.
It's like saying GPT-3 is a brilliant poet, but might not be the best chess player.
That's a perfect analogy, on the other hand. A smaller model like Distilbert, which is known for its efficiency, surprised everyone by achieving impressive results on tasks involving sentiment analysis and question answering.
So even though it's smaller, the Stillbert was able to hold its own against the giants in certain areas. It's amazing. Does this mean we might see a shift towards smaller, more specialized LLMs in the future?
It's definitely a possibility, especially as techniques like IB fine-tuning continue to evolve. It's all about choosing the right tool for the job, and this research is showing us that sometimes smaller and more focused can be just as effective, if not more so, than bigger and broader.
That's such an empowering message. It's not always about having the biggest and most powerful model. It's about understanding the strengths and weaknesses of each model and using them strategically.
Precisely, and this research is giving us valuable insights into how to make those informed choices.
I'm so glad we went on this deep dive today. It's opened my eyes to a whole new world of possibilities within the realm of LLMs. But we're not done yet. There's still more to explore, more insights to uncover.
You're right. There's one final aspect of this research that I think our listeners will find particularly fascinating. The researchers decided to explore the potential of applying IB fine-tuning to LLMs that work with different types of data, not just text.
Wait, hold on. You're telling me IB could work beyond the world of text that opens up a whole new universe of possibilities? What kind of data are we talking about here?
They looked at everything from images to music to even time series data, which is essentially data collected over a period of time, and the results were truly eye-opening.
Okay, now I'm really intrigued. Tell me more. What did they find when they applied IB to these other data formats? Did it work as well as it did with text?
Well, the findings were a bit mixed, which is to be expected when you're venturing into uncharted territory, for instance. When they applied IB to an image recognition model, they found that it significantly reduced the model's size without sacrificing much accuracy.
So you could have a much leaner image recognition model, which would be incredible for applications like mobile devices or self-driving cars, where efficiency is key.
Exactly. However, when they tried applying IB to a model that generates music, the results were a bit more challenging. They found that while IB could compress the model, it sometimes led to a loss of creative nuance in the generated music.
That's interesting. So while IB might be a game changer for certain data types, it might not be a universal solution.
You're catching on, and that's the beauty of research. It's about exploring the unknown, discovering what works and what doesn't, and pushing the boundaries of our understanding. This deep dive has been an incredible journey. So far, we've explored the core concepts of IB fine-tuning, we've peeked into the model's mind, through attention visualization, we've witnessed an AI decathlon, and now we're venturing into the exciting realm of applying IB to different types of data. What a whirlwind. And the most exciting part is that this is just the beginning. This research is laying the groundwork for a future where AI models are not only more powerful, but also more efficient, more accessible, and more understandable.
I'm absolutely buzzing with all these new insights. But before we get too carried away, I think it's time for us to take another quick break. When we come back, we'll wrap up this deep dive with some final reflections and explore the potential impact of IB fine-tuning on the future of AI. Stay tuned. Welcome back to the deep dive.
Yeah.
Before the break, we were talking about how researchers took IB fine-tuning beyond just text.
Right.
They actually started experimenting with other types of data, like images and music.
Yeah.
And it sounds like they found some promising results, but they also ran into a few challenges along the way.
Yeah, that's right. It's still early days
Right.
for applying IB to, non-textual data.
Right.
But the early findings are definitely intriguing.
Yeah.
Like, for example, they saw significant potential in using ID for image recognition models,
Okay.
especially for applications where efficiency is, super crucial.
That makes sense. A smaller, more efficient model would be a total game changer for things like, self-driving cars or mobile devices, where processing power is limited.
Exactly.
But you mentioned there were some challenges too, particularly with music generation.
Right.
What happened there?
Well, they found that while IB could effectively compress the music generation model, it sometimes resulted in a loss of those, creative nuances and those subtle variations that make music so expressive.
So it's like the model became a bit too focused, losing some of the artistry in the process.
Yeah, that's a great way to put it.
It really highlights that delicate balance between, compression and preserving the richness and complexity of certain data types.
Right. It sounds like this research is opening up so many exciting avenues for exploration. What do you think the long-term implications of IB fine-tuning could be?
I think we're just scratching the surface of what's possible with IB.
Yeah.
Imagine a future where we can create these incredibly powerful AI models that are also incredibly efficient.
Right.
This could revolutionize fields like healthcare, education, even entertainment.
It's almost like we're giving these AI models a superpower, the
Yeah,
ability to like learn and adapt with incredible precision and efficiency.
exactly. And not only that, but IB also have the potential to make AI more transparent
Okay.
and understandable.
Right.
By visualizing those attention patterns, we can actually gain insights into how the model is thinking,
Right.
making decisions.
That's crucial as AI becomes more integrated into our lives. We need to be able to trust these models.
And understand how they work.
Absolutely. This research is paving the way for a future where AI is not only, more powerful,
Uh-huh.
but also more responsible,
Right.
more beneficial to humanity.
I'm walking away from this deep dive feeling incredibly inspired. What are some of the key takeaways you'd like our listeners to remember?
Well, first, I think it's important to recognize that the field of AI is constantly evolving. There's always something new to learn.
Yeah.
And techniques like IB fine-tuning are like pushing the boundaries of what's possible.
It's not just about creating, bigger, more complex models.
Right.
It's about finding smarter, more efficient ways to train and utilize these powerful tools.
Exactly. Second, I want to emphasize that AI is not a one-size-fits-all solution. Different models have different strengths and weaknesses.
Yeah.
It's crucial to choose the right tool for the task at hand.
It's like having a toolbox full of different instruments,
Right.
each designed for a specific purpose.
That's a perfect analogy. And finally, I just want to encourage our listeners to stay curious. Keep exploring the world of AI. There are countless resources available, online, offline.
Right.
From research papers to online courses to even local meetups.
Yeah, learning about AI can seem, uh, daunting at first,
Yeah.
but it's incredibly rewarding.
It is.
And who knows, maybe one of our listeners will be inspired by this research to make their own contributions to this, to this exciting field.
I wouldn't be surprised. The future of AI is in the hands of those who are, curious, creative,
Right.
passionate about using this technology to make a positive impact on the world.
This deep dive has been an incredible journey.
Yeah, it has.
We've, explored a groundbreaking technique, witnessed an AI showdown, glimpsed the vast potential of IB fine-tuning. But, most importantly, we've hopefully sparked your curiosity.
Right?
And empowered you to further explore the fascinating world of AI.
Absolutely.
So, until next time, stay curious.